For the question 2, collect the definitions of probability and stochastic process. For the first one, Weissen's stationary process. So a stochastic is called a Weissen stationary if its mean is a constant and autocorrelation is a function of time difference. Since the Weissen stationary only care about means and autocorrelation, therefore we only focus on input and output, and the value during the process is not that important. For example, in communication, we only focus on input, the power of the signal, the correlation function are T1, T2 for T1 equals to T2. And then for the second one, the independent incremental process. So the independent increment process is xt1 minus xt2 and xt3 minus xt4 on non-overlapping intervals are independent. And for the third one, the Markov process. The Markov process means that if a process xt has a past that has no influence on the future when the process is known. For example, the binary transmission is a discrete state Markov process. And then for the fourth one, the normal process. The normal process, which is a Gaussian, is a process that xt is said to be normal if the random variable x1 t1 xt2 and stn are jointly normal for any n, and any t1 t2 to tn, that is fx x1 x2 to xn, and t1 t2 to tn is equal to 1 over square root 2 pi to the power of n and square root of d et and constant c multiplies the e to the power of 1 over 2 and x minus mean to the power of t multiplies c minus 1 multiplies s minus n, and where x is in this one, the variable x is that one, and the mean and the c. And then the fifth one, the strict sense stationary process. The statistics of a normal process is determined by mean t, the mean t, and the autocorrelation are t1, t2, and the mean t is a function of t, and the process is said to be a strict sense stationary process if it statistically is not affected by a shift on the time axis. And then for the sixth one, the white noise. The white noise is useful when we need to define a more general white noise with the zero mean and impose autocorrelation function. Wt is continuous with probability 1. It has different differential derivative Wt multiplies Vt, which is equal to differential of Wt is a Gaussian white noise with zero mean and impose autocorrelation function. A stochastic process Vt is said to be white noise if Vt is equal to 0 and autocorrelation Rt1 T2 is equal to Qt1 and the impulse of T minus T2. And then for the seventh one, the mean ergodic process. A stochastic process is said to be mean ergodic process if the limit of t is going to infinity of the 1 over 2t from minus t to t, the cumulative of x dt is equal to the mean in the mean square sense, which is a kind of consistency. And then for the last one, the martingales, is that if e xt, and then the condition of x s is equal to x1 and this expectation is equal to x1, where the s smaller than t for a stochastic process xt. Thank you.